Use the standard normal distribution or the t-distribution to construct a 95% confidence interval for the population mean. Justify your decision. If neither distribution can be used, explain why, and interpret the results. In a random sample of 17 mortgage institutions, the mean interest rate was 3.45% and the standard deviation was 0.49%. Assume the interest rates are normally distributed. So for this problem, we're going to use a t-distribution. We're dealing with a random sample, sigma is unknown, and the interest rates are normally distributed, which is why a t-distribution will work perfectly for this. So the next step is to construct the 95% confidence interval. And we'll be using the formula for confidence interval that includes our error, which will be t sub c times the standard deviation. And in this case, instead of using s, we'll go ahead and use we'll use s. And that will be over the square root of the sample size n. Therefore, our formula, which is going to put mu in the middle, will be less than or equal to x bar, or sample mean, plus the margin of error. And on the other end, we will have our sample mean x bar minus the margin of error. And this will give us our confidence interval. So now we need to go ahead and create our error. So we need to find t sub c using degrees of freedom for this problem. The degrees of freedom for this is going to be equal to n minus 1. In this particular case, n is equal to 17. And therefore the degrees of freedom will be equal to 17 minus 1, which will be 16. And now we need to go ahead and use our t-distribution table for degrees of freedom equal to 16 and a 95% confidence interval. This table is contained in the textbook. It is table 5 in the appendices that contain all the tables. So we go ahead and we find degrees of freedom in the table, which as we said is 16. We go ahead and find the level of confidence, which will be across the top. That's going to be 95%. And then we find out where the row and the column intersect, which will be at 2.120. So that's going to be the value that we're going to use for t sub c. So let's create our confidence interval. Remembering that E is going to be equal to 2.120 times your standard deviation. So we'll go back and we'll double check what our standard deviation is and what our mean is. Standard deviation is 0.49%. The mean interest rate is 3.45%. So now we'll go ahead, write that down. So x bar is equal to 3.45%. Standard deviation S will be equal to 0.49%. So we have 0.49 in the numerator here, and we have the square root of 17 here because we know that n is equal to 17. So when we calculate that, we end up with E is equal to 0.2520. That's carried out 4 decimal places. There might be a little bit of round-off error inherent in this, and if we wanted to completely mitigate round-off error, we would write everything out as such. So that would be equivalent to 3.14, 3.45 minus 0.2520 less than or equal to mu less than or equal to 3.45 plus 0.2520, which is going to give us the following values. This will be 3.198 less than or equal to mu less than or equal to 3.7019, and then we will go ahead and round to 2 decimal places, so this will be 3.20 less than or equal to the mean mu less than or equal to 3.70. And therefore, if we want to write it as a confidence interval, we can write it open parentheses 3.20 comma 3.70. Therefore, with 95% confidence, it can be said that the population mean interest rate is between the bounds of the confidence interval.